Okay, so in the previous two videos, we talked about finding asymptotes and intercepts. In this last one for this section, we're just gonna use those concepts to get a quick sketch of what this rational function is going to look like. So for VA, we know we're gonna set the denominator equal to 0. And we've already done this in the other videos for this problem, but we'll go ahead and do it again, which means x has to be equal to 3 for our VA. For the HA, we're going to do the degree analysis. And again, we've already done this in the previous video too, but y is going to be equal to the leading coefficient of the numerator and denominator because the degrees are the same. So since same degree, we're just going to take the coefficient from upstairs divided by the leading coefficients from downstairs. So y equals 2 is our horizontal asymptote. For the x-intercept, we said you pretty much end up just setting the numerator equal to 0 once you do the math, and you multiply both sides by that denominator. So we'll just go ahead and do that and say that is the x-intercept. So that's the ordered pair that it produces. And for the y-intercept too, we've already done this, but we'll do it again. We'll have, it looks like 0. So the origin is the x and the y-intercept. We're going to go ahead and use these ideas and get a quick sketch. So we have 1, 2, 3, 4, let's say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Vertical asymptote at 3. Remember, these are never crossed, so I'll leave it dashed. Horizontal asymptote at 2. And these may be crossed. For this one, it's a quick, simple one. We won't check to see if it's crossed or not. For the second part of this section, we'll go and see if there's to make sure that the horizontal asymptote doesn't get crossed. So for this quick sketch, we got those two guys. So we got this under control, and then I have that ordered pair that my graph goes through. So since my graph goes through that, I'll make it in red because the asymptotes are not really part of my graph. They just tell me what's going on with the graph. And since I know asymptotes are always approached through the origin, the asymptote has to get approached. So I'll go approach that guy. And through the origin, it has to go and it approach this asymptote. So that's my only option basically for what's happening to the left of 3. Since I have to have that ordered pair 0, 0, and since my asymptotes have to get approached in the long run, I'm just going to say that's generally what it looks like. Now, I don't know what's happening on the right. Maybe I have something here, or maybe I have something there. I don't know. And to confirm that, I'm just going to go choose, like, let's say x equals 4. Anything to the right you want to pick is fine. I'm going to put 4 and go put it in my function. So my function is right here. If I put 4 in there, I'm going to have 4 minus 3. That's going to give me 8 over 1, which is 8. So when I have 4, the output is 8, let's say somewhere over there. And that pretty much tells me what my sketch is going to look like. It has to approach this asymptote, and it has to go and approach the other asymptote. So that must be the general shape of this graph without having to refer to my TI. And again, in the next part of this section, we will do it by hand, look at the details, and then also go look at the TI. But this was just a quick one where I use my asymptotes and my intercepts. And basically with just those two ordered pairs, I have an idea of what the shape of the graph is doing by simply approaching the asymptotes. Now let's go put the math notation. From the graph, we can see that as I go to 3 from the right, so if I'm walking to 3 from the right, my x value of 3, I'm walking to it from the right, the y values are blowing up and going to infinity. So y is going to positive infinity when I walk from the right. Now if I go walk there from the left, so now I'm walking towards 3 from the left, well, I can see that the y values are shooting down to negative infinity. So notation wise, remember we said once you approach the asymptotes, they're going to blow up, go to infinity, or go down to negative infinity. So these were the VA information. Now for the horizontal asymptotes, so these two guys gave me VA info. As x goes to infinity, what's happening to my y values? Well, based on my graph, as I'm walking over to infinity, going all the way to the right, it looks like my y values are being capped and trapped to approach this number 2. So as I go to infinity, my y values get closer and closer to 2. And similarly, if I walk over to negative infinity, so if I'm walking over to negative infinity, let me use green again. If I'm walking over to negative infinity, my y values are again being capped at that 2 and being trapped under 2, so y values go to 2. And this is the information for the HA. So notation-wise, with infinities and arrows and numbers from the right, from the left, that's how we would represent how mathematically the horizontal asymptote is behaving and how the vertical asymptote is behaving. And from the graph, we can see the domain and the range. Well, we already know the domain has issues at 3, so we can say that x such that x cannot equal 3. That would be probably the quickest way to say that, because the denominator becomes 0 when x is equal to 3. Or if you're putting it in interval notation, just exclude 3 and pick up negative infinity to infinity otherwise. For the range, notice there's also a gap. So for the range, I have stuff down here, and then there's a gap for my y values, and then I pick up stuff up there. So I'm noticing what y value is my 2 pieces of the curve. This guy and this guy are picking up. And so it's all the y values from below, and then you have a gap at 2, the horizontal asymptote, and then you pick up again after that. So we'll say the range is all the y such that y cannot be 2, or negative infinity to 2, and then 2 to infinity, again, because of that gap that was there for the y values. Now remember we said, hey, what if the horizontal asymptote gets crossed? What if there's something like this happening, crossing and coming back down? That is possible in some graphs, but in this case, for the sake of simplicity of this problem, that won't happen even when we do the check. All I need you guys to know for right now is know the vertical asymptote, know the horizontal asymptote, know the x and y intercepts, and get a sketch going. And of course, you can always confirm that on your TI also to see what the shape looks like.